Green hydrogen, often referred to as clean hydrogen, is produced by the process of electrolysis, where water molecules splits into hydrogen and oxygen using electricity. The defining characteristic of the green hydrogen is that the electricity used in this process comes from the renewable sources of energies like solar, wind, hydropower, making it sustainable and eco-friendly than other alternative traditional hydrogen production methods. In this video, we will explore how the use of fossil fuel induces the global warming and its transition to hydrogen energy with simultaneous replacement of the batteries for energy storage. So, without wasting any time, let's dive into this topic.
Serious about hydrogen's place
green hydrogen
in green hydrogen.
And hydrogen.
Greenhouse gases such as carbon dioxide, methane, nitrous oxide, and fluorinated gases allow sunlight to enter into the Earth's atmosphere but prevent it from leaving there, thereby increasing the surface temperature of the Earth. This is known as global warming. Although fluorinated gases are the most potent in causing global warming, but carbon dioxide contributes 80% in causing global warming on Earth due to its maximum relative presence in the air. The day-by-day increase of carbon dioxide proportions in air is due to the uncontrolled burning of fossil fuel, deforestation, and urbanization. Fossil fuels such as coal, natural gas, and crude oil are collected by digging deep into the Earth's surface. According to the International Energy Agency, in the year 2022, around 82% of the world's energy dependence were met through the fossil fuel consumption. But the rapid consumption of the fossil fuel to meet the global energy demand concerned various governments on two fronts. First, global warming. Second is the energy crisis in the near future due to the decline of fossil fuel reserves. Thus, governments focused on renewable sources of energies like solar energy, wind energy, geothermal energy, hydroelectric energy, and energy generation from the tidal streams and sea waves. Like US government set out a target of achieving 80% of its energy need through non-fossil fuel or renewable resources by the year 2030 and zero carbon footprint on its energy need by the year 2035. Whereas Government of India aim to achieve 500 gigawatt of installed capacity of electricity through non-fossil fuel by the year 2030. Among various renewable sources of energies, solar energy via photovoltaic cell and wind energy are the most popular one. But unfortunately, both the solar energy generation and wind energy generation are highly dependent on location and weather conditions. These constraints pose problems since very often the timing of energy supply and energy demand do not coincide. For this reason, energy storage technologies play a key role so that the energy produced from these renewable sources of energies can be fully harnessed. And when we talk about the storage technologies, one thing that comes in our mind very firstly, and that is the battery. A battery is where chemical energy is converted into electrical energy or vice versa. But this battery technologies has also several limitations, like limited number of useful cycles, that is charge or discharge, use of critical raw materials or polluted compounds, etc. Due to all these limitations in solar energy and wind energy, hydrogen is taking place much of its attention as an alternative source of energy as well as an alternative energy storage. Hydrogen is most abundant in the universe. An atom of hydrogen is symbolized as H letter, and two of its atoms combine to form molecular hydrogen. Stars like Sun are all composed of hydrogen, where nuclear fusion continuously goes on. Hydrogen is also abundant on Earth's surface in the form of water. Molecular hydrogen is not so much present on the Earth's surface until it was discovered while drilling a well in the year 1987 at a village in Canada. Molecular hydrogen are found underneath the Earth's surface due to a hydrothermal reaction of the iron rocks with the subsurface water. Here we will discuss hydrogen in three chapters. First chapter, hydrogen as an alternative source of energy. In the second chapter, hydrogen production. In the third chapter, we will discuss hydrogen as an alternative energy storage. Chapter 1, hydrogen as an alternative source of energy. Prior to know how we can use hydrogen as an alternative source of energy, we need to know what is a fuel cell. A fuel cell is just like a battery, where fuel is fed into the system to generate the electricity. Also, the fuel cell does not have any charge-discharge cycle. As long as fuel can be fed into the system, it will generate the electricity. There are multiple types of fuel cell where hydrogen is used to generate electricity. But two common types which are used are solid oxide fuel cell or SOFC and polyelectrolyte membrane fuel cell or PEMFC. SOFCs are so named as it consists of solid electrolytes such as doped zirconium oxide, which is porous in nature also, so that fuel and oxidants can easily pass through it. In this typical fuel cell, hydrogen is fed into an electrode, typically anode, where it releases electrons, and that electrons flows through the outer circuit of the cell and reaches cathode, where it combines with the oxygen atoms to produce oxide ions. These oxide ions pass through the solid oxide's pores and reaches the anode, where it combines with the protons or hydrogen ions to produce water. In polyelectrolyte membrane fuel cell, a polymer is used as an electrolyte such as naphthalene. Here also hydrogen is fed into the anode, where it releases electrons, and the released electrons flows through the external circuit and reaches the cathode, where it combines with the oxygen atoms to produce the oxide ions. But there is a basic difference between the polymer electrolyte membrane fuel cell and the solid oxide fuel cell. In solid oxide fuel cell, oxide ions travel through the doped zirconia to reach the anode, where it combines with the protons to produce the water. But in the polymer electrolyte membrane fuel cell, protons or hydrogen ions travel through the polymer electrode and reaches the cathode, where it combines with the oxide ions to produce the water. So in this way, the electricity can be generated through this fuel cell as long as hydrogen is fed into the anode. Chapter 2: Hydrogen Production. Hydrogen can be produced in different paths, and depending on the environment impact, such as the volume of carbon dioxide emitted during its production, each path has been assigned to different color codes. And there are typically 6 paths from which hydrogen can be produced. First, white hydrogen or geologic hydrogen, which occurs naturally deep underneath the Earth's surface and produced by drilling the Earth's surface. Second, black hydrogen, which is produced from gasification of the coal. Third, grey hydrogen, which is produced from fossil fuels. Fourth, green hydrogen, which is produced from water splitting via electrolysis. Fifth, blue hydrogen, where hydrogen is produced from steam methane reform of natural gas. In steam methane reform technique, methane is made to react with steam under heat and pressure to produce hydrogen. And finally, hydrogen produced using nuclear energy via water electrolysis is known as pink hydrogen. Amongst them, green hydrogen production can be made zero carbon emission if the power or energy required to split the water molecules used from renewable sources of energy. And thus, hydrogen can be produced in different methods and very easily, so that hydrogen can be used as an alternative source of energy. And in the next chapter, we will discuss about how hydrogen can be used as an alternative energy storage. Chapter 3: Hydrogen as an alternative energy storage. In case of electricity generation from solar energy and wind energy, where constant supply of electricity is quite challenging, hydrogen can be used as an alternative source of energy in replacement of battery or supercapacitor. Converting the excess electricity produced from solar energy or wind energy into hydrogen and then reconverting the hydrogen into electricity can be a good alternative to the battery or supercapacitor. And hydrogen can be stored in 3 different ways. First, hydrogen can be stored as compressed gas under 350 to 700 bar pressure in physical storage vessels or some geological storages like salt caverns in depleted oil and gas reserves or in aquifers. Countries like US and Germany already started their projects to build geological storages to keep hydrogen in it. Second, hydrogen can be stored in liquid form or as liquid hydrogen in cryogenic condition that is at around minus 253 degrees Celsius. Third, conversion of the hydrogen into ammonia for low cost transportation, where ammonia is reconverted into hydrogen at destination. So, hydrogen is the potential alternative to meet our energy demand in the near future. This alternative source of energy is also more efficient than gasoline. And We don't need any batteries to drive motors in electric vehicles or in other applications. And this is eco-friendly too if we generate the hydrogen by water electrolysis using renewable sources of energies. Not only that, oxygen is produced as a byproduct during water electrolysis, which is also a value-added product for us if we supply this oxygen to medical industries or any other industries where oxygen is much needed. Despite all this technology has several limitations. Hydrogen is highly flammable in air and it can be ignited easily, which can pose many problems during its use. And also, a huge expenditure is needed for its storage tanks and transportation. But as per an American writer, Brendan Francis, the best way to escape from a problem is to solve it. Designing of hydrogen storage tanks and precise detection of any hydrogen leak are the most challenging jobs in safe handling of the hydrogen. Government of India has also started allocating its budget for its ambitious green hydrogen project named as National Green Hydrogen Mission. This mission aims at making India a global hub of green hydrogen production, utilization, and export with conducive research and innovation ecosystem. Hey everyone, thanks so much for watching this video. If you enjoyed this video, please give it a thumbs up and subscribe for more content. And I will see you in the next one.